Okay, we're into section 4 of chapter 8 now. This one's called special products. So previously we multiplied binomials using the FOIL method. Now we're going to multiply binomials in some special cases, why it's called special products. So we're going to find the squares of sums and differences and find the product of a sum and a difference. So that's kind of the vocabulary. Sum of a square, or square of a sum, square of a difference, product of a sum and difference. So Colby wants to attach a dartboard to the side piece to a square piece of chalkboard. If the radius of the dartboard is r plus 12, how large does the square chalkboard need to be? Well, Colby knows that the diameter of the chalkboard is twice the radius, so 2 times r plus 12, or 2r plus 12. Each side of the square also measures 2r plus 12, or plus 24 rather. To find how much the chalkboard is needed, Colby needs to find the area of the square. Area is side length squared, so the side length is 2r plus 24. You got to square that. Well, some pairs of binomials, such as squares, like 2r plus 24 squared, have products that follow a special pattern. Using the pattern can make multiplying easier. The square of a sum, a plus b quantity squared, or a plus b times a plus b, is one of those products. Here's what you do not want to do. You do not want to do a plus b squared is equal to a squared plus b squared. That's the biggest mistake that I see students make. Now, if it's the square of a product, if it was a times b, then squared, then you could, yeah, that's the product to a power property that we learned in chapter 7, then you can put the square on every term or every factor that is in the parentheses. But if you're adding or subtracting inside the parentheses, you cannot just distribute the square, okay? So if you think of a plus b times a plus b, it's like you have a square, and one side length is a plus b, and the other side length is a plus b. So if you multiply it, you would have a times a, which would give you a squared. This one would have dimensions of a times b. This one would have dimensions of a times b, and this one would have b squared. So you can see, right from looking at it, that you get an a squared. You have two factors of, or two terms of a plus b, and a b squared. So the square of a sum, you can use the FOIL method, okay? It's not wrong to use FOIL or anything like that, but this is just a special product, the square of a sum, that you can do it in this manner. All you do is square the first term. So in this example, x plus 4 quantity squared. You square the first term, then you're going to end up with two. The outer and the inner are going to be the same, so you end up with two of them. So that's twice the two terms multiplied together. So x plus 4, or x times 4 multiplied by 2 is going to give you 8x, and then the last term squared. So it's the first term squared, twice the product of the two terms, plus the last term squared. All right? So if I want to find 3x plus 5 quantity squared, it's a special product, so I use the square of a sum idea, and I just square the first term, multiply the product, twice the product of the two terms, and then square the last term, which would give you 9x squared plus 30x plus 25. All right, so here's a couple for you to try. Remember what the formula is for the special product, the square of a sum. Go ahead and try it. Okay, we're back. So the first one, remember, you square the first term, double the product of the two terms, and then square the last term. And remember, if this starts to get confusing, all you have to do is rewrite that as 8c plus 3d times 8c plus 3d, and then FOIL it. This is just kind of showing you a shortcut to FOILing. All right, and then if I simplify that, 8c quantity squared, you would square the 8, square the c, and you would get 64c squared. 8 times 3 is 24 times 2 is 48 CD plus 9D squared. Okay? Same thing with this last one. If trying to use these special products formulas gets confusing, all you have to do is write it out and FOIL it. Okay? So in this one, using the special product, you square the first term, double the product of the two terms, and then square the last term. So you would get 9x squared plus 2 times 3 is 6 times 4 is 24xy plus 16y squared. All right? Okie dokie. All right, there's also a pattern for this square of a difference. So if you have a minus b squared, you can think of it as a plus a negative b and then use the square of a sum pattern. But basically what it turns out to be is that you get the first term squared, then minus the product of the 2ab, and then the last term squared again, okay? So let's try an example here. Again, if this gets confusing, just write it out as this minus this times itself and then FOIL it. But we're going to do the square of a difference here. So you square the first term, subtract twice the product of the two terms, and then square the last term. All right, so this one would be 2x minus 5y quantity squared, so you have 2x squared, first term squared, minus twice the product of the two terms, so 2 times 2x times 5y, plus the last term squared. Okay, and you might be thinking, well, since this is subtraction, why wouldn't this be subtraction? It's because if you actually FOILed it out, you would have negative b times negative b, which would be positive b squared. In this case, you'd have negative 5y times negative 5y, which would give you positive 25y squared, like we have here. So this simplifies to 4x squared minus 20xy plus 25y squared. All right, again, here's a couple for you to try. Go ahead and pause the video. Okay, we're back. So the first one, you do 6p first term squared minus twice the product of the two terms plus the last term squared. So you would have 36p squared minus 12p plus 1. All right, that's your answer right there. Next one, you have the first term squared minus twice the product of the two terms plus the last term squared. So you would have a squared minus 4ab plus 4b squared. Okie dokie? All right. So the product of a square or a sum, the product of the square of a sum or the square of a difference is called a perfect square trinomial. And we can use these to find patterns to solve real-world problems. So each edge of a cube of aluminum is 4 centimeters less than the edge of a cube of copper. Write an equation to model the surface area of the aluminum cube. So this is the copper one. The aluminum one is 4 centimeters less than that, so C minus 4. So let C equal the length of each edge of the cube of copper. So each edge of the cube of aluminum is C minus 4. The surface area of a cube is 6 times the area of one of the faces. Okay, so since it's a cube, all the faces are squares, and the reason we multiply that by 6 is because there's 6 sides to a cube. Also, surface area you can think of is how much wrapping paper would you need to perfectly wrap that with no overlap. Okay, so it's 6 times the square of each, the area of each side. So the area of the square is going to be s squared. In this case, the side length is c minus 4, so it's going to be 6 times c minus 4. Well, c minus 4 quantity squared is a perfect square of a difference, so I can use the formula for that. So it's going to be 6 times the square of a difference formula. So it's the first term squared minus the double the two terms multiplied together, plus the last term squared. So it's 6 times c squared minus 8c plus 16. All right, and if you could distribute the 6 here and get 6c squared minus 48c plus, all right, what's 6 times 16? 6 times 10 is 60, so that'd be 96. Okay, all righty. All right, Alano has a garden that is g feet long and g feet wide. He wants to add 3 feet to the length and width. Show how the new area of the garden can be modeled by the square of a binomial. Find the square of this binomial. All right, go ahead and pause the video. All right, so in this problem, the length equals the width, which is g. So he has a square garden. It's g by g. He wants to add 3 feet to the length. So this side would be g plus 3. And this side would be g plus 3 also, 3 feet to the length and width. Okay, so the new area of the garden can be modeled by the square of a binomial. So part A, the area would be g plus 3 times g plus 3, or g plus 3 squared, not cubed, squared. All right, part B, you could FOIL that out, but since it's the square of a sum, I can use the formula where you square the first term, double the product of the two terms, and then square the last term. So you would get g squared plus 6g plus 9. Okay? Alrighty. All right, guys, that's it for this video. Please stay tuned for the next one where we'll finish up this section. See you there.